We basically, again, because of our goofy country that we live in as far as, you know, figuring out what's easiest and what's hardest here. We have two different measurement systems that we use. We'll just jot those down. We have our system, which we call the Fahrenheit. I believe this is how you spell it. The Fahrenheit way, and we have the Celsius. Wait, did I spell that right? Why doesn't it look right?
Because
Sometimes when you get too close to things, do you think there's two H's in Fahrenheit?
maybe it's just your handwriting.
It is. I need to work on my handwriting. I really do. Well, until I find it, I'll just leave it up there like that. And here's the deal, children. And temperature is measuring how warm or cold something is. Here is the difference in the two systems here. And we always, even though we're not really, we don't usually use these type of thermometers anymore. Why don't we use the little bulb thermometers anymore? Who knows why, Ryan? Yeah, usually the way they made these was out of mercury. Maybe they could make them out of something else. And mercury, it was decided that mercury is just not a good thing for us as humans. So they don't make them too much anymore here. But here's the deal. We have two standards in both of these, okay? Somebody decided way back when that we've got two gauges that we use. And the first one is, when does water boil? When does water boil? That means when you put it on the stove. At what point does it start to bubble up and become a gas? Well, in our Fahrenheit system, and again, I don't know why they chose this number, but it ends up being how many degrees in Fahrenheit? Nicholas?
212.
Right, 212 degrees. At 200 degrees Fahrenheit, with the letter F, the big capital F there, that's when water starts to boil. In Celsius, to me, it makes a lot more sense. In Celsius, water boils at 100 degrees Celsius. Okay? And then probably obviously, if one temperature is when water boils, the other temperature we're going to look at is, when does water freeze? At what point does it become a solid then? And again, in Fahrenheit, don't know why, Jacob, it is
32.
right, 32 degrees. And in Celsius, making more sense, water freezes at, Michael? 0 degrees. Okay? So those are the different scales. To me, the Celsius one makes a little more sense because it's, you know, it's almost logical. It's easy to remember. Okay? But, how does the Celsius, how does 1 degree Fahrenheit compare to 1 degree Celsius? If between freezing and boiling there's only 100 here, and between freezing and boiling there's, well, 180 here, you know, which temperature, going up 1 degree is going to mean more in which one of those two? In other words, if the temperature raises 5 degrees, is that going to be more in Celsius, or is 5 degrees, getting 5 degrees warmer in Fahrenheit going to be warmer? No, Celsius is actually, these increments, because there's only 100 here, each increment stands for more. For example, on a pretty warm day out, an 80 degree day, I don't know if I know the exact, now talk, let's see, 80 degrees is maybe about right here. 80 degrees Fahrenheit would be about what Celsius? Yeah, let me see if they got one here where it compares them. I don't even see one here. 80 degrees Fahrenheit is about what Celsius? Oh, there it is. Oh, it doesn't, no, it doesn't show. 80 degrees is somewhere around what, Gary?
62.
No, 60 is way high. You would not be able to stand 60 degrees. If you think about it, 50 degrees is halfway up this scale. What's halfway between 212 and 32? Remember, how do we find halfway? Add them together, divide by 2, find the average. So if I did 212 plus 32, added them together, I don't know why this isn't working. What's half of 244? 122. So 50 degrees Celsius is the same thing as 122 degrees Fahrenheit. So it's going to be lower than 50 degrees there. It's actually more like, I don't know why it's starting to freeze on me here. It's more like 20 degrees, probably 22 or 23 degrees. That's kind of the gist there. Uh-oh. They get locked up for good. 122 degrees. Come on, thing. In the same way, if you think about, what happens when the temperature gets below freezing? Okay. Oh, there we go. Uh-oh. It's moving by itself. What do we do when numbers go below 0? We use negative numbers. For example, -5 degrees. How cold really would -5 degrees Celsius be? That's what we talk about in Fahrenheit. -5 degrees would be, if you were guessing, Jacob?
20?
Yeah, probably something like that. Probably about 20 degrees or so. You're probably not far, maybe 18 or 19 degrees. Okay, so when you get below 0 here in Fahrenheit, let's say it's 2 degrees below 0, what do you think? How far below Celsius do you think that would be? I wish I don't have one here where it compares them to me for me. It's going to be quite a bit below 0 here. It's almost a 2-for-1 differential there. So, when you're talking about this, it's going to be, who knows, maybe 16, 17, 18, 20 degrees below 0. So you have to be very careful when you look at the systems and the things to know if you're in Celsius or Fahrenheit because there's a big difference there. For example, if your mom said, make sure you dress appropriately, it's 20 degrees outside. Well, if you're talking 20 degrees Celsius, that would be shorts weather. If you're talking 20 degrees Fahrenheit, that's winter coat weather. So make sure you know if your mom says that. Again, we pretty much strictly still go by this, and I don't know why. That's just kind of a goofy thing. We really should go to the other system because it makes a lot more sense, but who knows. Let's look at some of the lesson practice things here. See if we can get some questions here. What are we at, 98? Temperature, lesson practice. See if you can answer this. Use digits and symbols to write the temperature that is 12 degrees below 0. How would you write 12 degrees below 0 Fahrenheit? How do we show below 0? Gary? Yeah, you use a minus sign. If you put a minus sign in front of it, that means it is below 0. Okay, so this would be minus 12 degrees, and you got to make sure you label it, because if you don't label it, then we're in trouble. What temperature is shown here on the thermometer? And here you have to be careful too. Look, here is 0 degrees, and it's below that, so it's going to be below 0. And then you have to figure out what does each one of these marks stand for. How many degrees is each mark? Jacob?
1?
Well, let's check and see. 1, 2, is there 10? Is there 10 marks between 0 and 10? 1, 2, 3, 4, 5, yep. So what does this mark stand for, Peter?
-5 degrees.
Correct, -5 degrees Celsius. And how cold do you suppose that is in Fahrenheit temperature? Would that be super cold? Would that be freezing cold? Would that be kind of cold? Incredibly cold, Gary?
Probably at the highest 15 degrees or so.
Yeah, it's probably around 15 or 20 degrees. So it's bearable. It's not like you're going to walk outside and freeze in the first 30 seconds. Letter C, if the temperature shown on the thermometer is 14 degrees lower than the high temperature for the day, what was the high temperature? How would you figure that out? If this shown is 14 degrees lower than the high temperature, what temperature would that be? In other words, you're going to have to go up 14 degrees here. So let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 degrees. Oh, thank you. Stop would be right there, which isn't working. How many degrees would be 14 degrees? Nick?
9 degrees Celsius.
Yep, it would be 9 degrees Celsius. That's, by the way, your first introduction into adding negative numbers. A -5 plus 14 degrees. I always like to think of that like money. Negative money is like money you owe. If you owe somebody $5 and you have $14, you have to give them the $5 you owe them, and you'll still have $9. That's kind of handy, isn't it? How about letter D? If the temperature falls 3 degrees from the temperature shown, what temperature will it be? If it goes down 3 degrees, what temperature will that be? So that means now it's only to right here. What temperature is that?
If it goes down 3 degrees, what temperature is that?
Kelsey?
-8 degrees.
Very good. Okay, which means, again, if you do the math part of this, a -5 degrees minus another 3 degrees is -8 degrees. How about that?
Sooner or later, we'll do that negative positive stuff and you'll be all excited about it.
You don't have to understand it now, because they won't ask you that. If you draw the pictures, you can figure it out, so you are good with that. Alrighty,